ROV stands for remotely operated vehicles, so we're doing underwater robotics. A big part of what we do is simulating what ROVs do in the actual real world underwater in oceans and lakes. So we get to simulate all of those things in the pool, but we get to be connected to really global issues.
Each component of our ROV went through at least a dozen versions. Throughout all of our years of ROV, we've been slowly refining those designs to get the designs that we have here.
So this is the result of 1 year of work, but we've been modeling it after and adapting all of our previous years, so we're getting one really amazing robot afterwards.
This year we had to implement a micro ROV. One of the most challenging aspects of it was just being able to create a tether management system so that it would effectively be able to go down the pipe and then be able to retrieve itself back into the ROV.
We've put a lot of energy and a lot of hours in designing our manipulator, our claw. It can spin infinitely in any direction using stepper motors, and it can open and close while it's rotating.
Our cameras can go and pick up a bunch of shapes underwater and identify them as specific species that they are. So we had to write our own program in order to automatically identify those on the spot.
Knowing each other out of the team, I think really helps us be able to criticize each other more to to get sort of that perfect model that the judges want to see, so that it actually seems like your professional startup company.
I know that every single meeting I learn something new from every single person at the meeting. So we're really not just learning from the teachers and our mentors, but from each other, which is a really huge part of the experience.
We really got a lot from this program, and so one of the things we want to do this year before we graduate is to pay it forward and give other schools the opportunity to get all the benefits that we did from this experience.
We've already done a few workshops with people in elementary schools, and we gave them demonstrations with our ROV and gave a talk about what the program entails and what you actually can learn from it. We have two mentors, Victor and Mary DaCosta. And without them, this entire program wouldn't be anything.
When we were first starting out as a team for ROV in 7th and 8th grade, Victor and Mary really helped us build that base of skills that we could develop throughout the rest of our years for ROV.
If you think it's at all impressive that we've spent 1,000 hours on this project, it's even more incredible that Victor and Mary have been willing to dedicate their household where we spread out over the entire thing and just let us experiment and evolve and try ourselves in different ways and test ourselves, and just eventually, if we can't get the answer, they'll guide us to it and not just tell us.
Through 6 years of ROV and being able to learn the engineering process, being able to try, fail, and refine all of these designs, I was able to truly show to myself that I could be an engineer.
The skills I've learned at ROV have been extremely applicable in other walks of life. We've learned through this program that the way to succeed is through working hard, and that's what we've learned, and we hope we're able to implement and share with kids now as we're moving into the community.